Hello everyone, good afternoon. Hope you all are doing good. First of all, a big thank you from my side for making it to the session. I know it's after lunch, at the time of afternoon snacks, so people generally don't make it to the session, but I promise you the next 30 minutes, I will try my best to keep you engaged, keep this discussion flowing so that at the end of the session, we all have something to take from it. So with this, I will start. So as you can all see, my talk is titled From Config to Cloud, a Pythonic approach to platform independent design. The talk is like the topic of the talk is too long, does not give a lot of clarity, but we'll come to what the problem statement is in a while. Ultimately, it's all about building portable cloud solutions for an application so that it can, the last line gives it away. So what if your code does not care about where it runs? Whereas in the modern world, the world we are presently in, your code absolutely has to take care of where to run, what configs to make, and also if we have a better way to have this abstraction in place, why not? So with this, I will actually start my presentation. Kamusta everyone. My name is Anubhav Sanyal. I am originally from Bangalore in India, often also called as the Silicon Valley of India, obviously for all the good reasons. This is my first time in Philippines and I'm really excited to be here. I have always heard good things about Philippines and I now know why Philippines is rated so highly. Regarding my work, I currently work as a senior software engineer at National Australia Bank, often abbreviated as NAB, which is the second largest bank in Australian subcontinent and also the second largest bank in the southern hemisphere as well. So I'm majorly into platform engineering side of things, maybe some days into backend, but yeah, more on CI/CD DevOps infra side of the stuff. Before NAB, I worked with a startup called Swiggy, which was India's biggest startup back in the day in terms of valuation, ultimately becoming one of the first decacon startups of India. And before that, I started my career with ST Microelectronics, which is a semiconductor giant. So that's what my journey has been all about. On the right-hand section of the slide, you would find a QR code with the link to all my socials. It contains my link to LinkedIn, GitHub, Medium, Instagram, and all that stuff. I would really appreciate a follow because I would love to stay connected with you all. With this officially starting the talks. So I have the agenda slide over here. This is what we are going to cover in the next 20-25 minutes. So what I will do is I have broken my talks into two sections. The first 25 minutes for the talk and 5 minutes for the Q&A. I've divided the time appropriately. Hopefully I would be able to finish that stuff. I would want to keep this conversation going, flowing. I really appreciate the questions from the cloud. The slides are just there for the sake of it. I'm not using slides as much because I do have a code in place, so I can definitely show you the code, which makes much more sense. So wherever possible, with a live demo, with the code in place, we'll be moving over there. So obviously, like as you can see, I have divided the slides into 6 sections. One is the problem statement, then is the real world, why this is actually required in the first place. Then we move on to what is the vision, then the AWS implementation, the GCP implementation, and the conclusions and key takeaways. So yeah. Let's get started now. The fundamental question is, in the last decade, we have been building the cloud native applications. Cloud native applications as in applications which run on a cloud provider of your choice. Most probably, most of the terms, most of the enterprises, it's AWS, GCP and Azure catching up very soon. But most of the times, your application runs only on a single cloud. That is, if you have built your application, the entire architecture revolves around one specific cloud only. So let's say your application is in AWS, the entire architecture is based to suit that manner. So while there is cloud native applications, and that's a really justified term, we should be moving in a way where we are cloud agnostic as well. And the reason behind this is, I do have the sections in the next slide, but the reason behind this is the number of outrages that has taken place in the last few years. So don't get me wrong, I absolutely love AWS. AWS has been my bread and butter for the last couple of years now, but AWS has not been in its best form and shape for the last year or so, right? We have seen so many outages happen, yes, sometimes across regions, sometimes globally, and people might have a question on Okay, like I know, like let's say US East one goes down, why not have replicas or backups in US East 2 or maybe some other region, so that you are actually protected when things go wrong. And that's a valid way of looking into things. Like there's no problem in looking into that. Just that for some critical P0 businesses, the reliability is the most important way. So let's say if you are a grocery store owner or working in a transport startup, or let's say a food delivery app or something of that sort, no, multi-cloud is not for you because you can afford that downtime. Yes, there would be monetary loss in place. Yes, there would be business loss. There might be reputation loss as well. But at the end of the day, it's not anything critical that people lives are dependent on it. But in industries like banking, hospitals, airlines, right, you might have seen, like if let's say AWS goes down, which powers 40% of the world's businesses, your entire business goes down. You cannot afford to have a downtime in banking. Otherwise, how people would transact, right? And mostly if the cloud provider goes down, every bank across the globe or in that specific region goes down. So you have zero like stuff to get back into. Same for hospitals, like you cannot afford to have a downtime over here. So this is where multi-cloud makes a lot of sense, and this is generally for those industries. Startups, small ecosystems, no, I think you are all good with having single cloud provider in place and all that stuff with like scalability and backup setup. Just before proceeding to the next slide, I just want a quick show of hands regarding how many of you know about or have worked with, let's say, AWS or GCP, because this is what my entire slides would be all about. So if I could just get a quick show of hands, I would just manner my talk in that way. Oh, yeah, so some few hands, so all good. Let me now go to the next slide. So the next slide is technically like what has happened in the real world. So AWS did have an outage on, let's say, October 20th, if I'm not wrong. And I remember this day because this was a day when we celebrate Diwali in India, right? It's one of the biggest festivals out there. And an outage, a P0 outage on that day means the entire ecosystem getting affected. Microsoft also has an outage in the same month in October 2025. And Google Cloud's last major outage was on June 12th. So which essentially means that there have been multiple P0 outages over the last few years, over the last year, and things will increase. Like I did heard about a news saying Amazon internally checking all the usage of AIs so that their cloud can become more stable. So I mean, yes, like maybe there is light at the end of the day, but there's also, I mean, there's also a factor that we need to consider, that the outages might happen. It's always better to stay protected, to stay like to have a precautions in place. So yeah, the vision for this is, as I mentioned, we have to make cloud native but cloud agnostic applications. Pardon the title on the slide, it says cloud independent. Cloud independent is not the correct way. It should be cloud agnostic, because your applications should not care about where your on what cloud your application is running on. So just to give you an example, right, and things would get much more clear as we move on to the next slides. Let's say you have an application, right? In that application, like we define applications into two forms and states. One is a stateless application and another is your stateful application. Stateless applications are your normal microservices, right? And I do have an architecture in the upcoming slides. Let's say a loan service, which does not, like it's a microservice at the end of the day. You can very well containerize it. You can very well deploy it on any cloud. Does not matter, like you would be able to get it working. There's also type of apps or infras called stateful infras, right? Which is like your databases, your S3 buckets, your Redis, which contains data in them. So migrating those across different clouds, it's where the problem lies. So my whole of the slides would be divided into two sections, the stateless architecture and the stateful architecture, along with the code sample, so that it becomes pretty clear. So yeah, I mean, on this slide, and I do have a better picture on my GitHub repo, which I will just show you. We are actually, like, I'll be taking an example of an actual application which I have developed just for the demo purpose. Just to give you some context on this, this is a loan application, and known because I work for a bank, so I understand what happens. So this is a loan application, which I call it as decision service, the one in the green box if it's visible. It internally calls another service called a credit check service, right? Like one of the very significant flows that happen in any banking procedures. The moment you apply for a loan, right, a call is made to your, like whatever your credit authority is, just to check your credit score, whether you should be like given that loan or not, right? And as soon as the decision is received, the decision service is the one which makes the decision whether your loan should be approved or not. As soon as this is received, if your loan is all successful, you get a letter which is stored in a object store, can be an S3 bucket, can be a GCP bucket, but entire information is also recorded in your database. So as you can see, I have few movable components over here. The decision service and the credit check service are two components which are stateless services that I was mentioning. They are microservices at the end of the day. They do not care what happens, whether they get deployed. You obviously have to make it cloud native so that you can deploy it anywhere. But again, you also have the PostgreSQL DB and the S3 bucket, which are stateful services, and they have data inside it, which means you would have problems in managing this data or to move out this data from one cloud to another. So again, don't care about the picture in the slides. I have a better image out there in my GitHub repo, which I will just open in a moment. But if you were to just get this, this is how and where, like this is the service architecture in AWS. So on the left-hand side of the screen, you see there is a public subnet. In the public subnet, like I do have the decision service set up. In the private subnet, I have the credit check microservice over there. My DB resides in the private subnet, which means a private subnet is not supposed to have an internet connectivity by default, which means no people from the open internet can reach to it. Whereas in case of a decision microservice, because this is my public facing thing, it has to be open up and running to the public internet. Though I do not agree to this architecture per se, because this is not the most secure architecture. Ideally, you should have nothing in your public subnet. Does not make sense. But just for this demo purpose, like just to make my life easier, I put the front-facing application, which is a decision microservice, in the public subnet. And obviously, there at the bottom side, you see a S3 bucket. That's the logo for S3. It does not reside in a subnet because that's a AWS managed service. So this is what the architecture on AWS looks like. And this is the EKS architecture. Again, if you look at the EKS architecture, like it's the same thing, the public and the private subnet, just that mentioning that it is deployed on EKS. So what I will do is, I already have my GitHub set up. I will take you to this so that things make much more sense. And I will open this. So as you can see on my GitHub repo, like I have the repo structure. And you see there is one thing called decision service and another folder called credit check service. This is where the entire code of these services resides upon, right? And if I were to go to presentation slides, and over here the AWS deep dive, you would find a better image of what I was telling you, so that like you get an idea of the entire architecture. So for a customer or for a user who is using it at this point in time, like decision service is the one that you are supposed to interact with, right? So I will open my Postman, and on my Postman, as you can see, I have told you that I have a like decision service is there in the AWS public subnet, which means I have a public facing IP. I can obviously hit it and see if it's up and running or not. So for this specific, like if you look at this, this is the API which it exposes. And if you look at the body of this API, just give me a second. Yeah. If you look at the body of this API, you would see the parameters, like it contains my name, my date of birth and stuff like this. Just a dummy API call happening, makes a check to the credit service, and you get a result at the end of the day whether your loan is approved or not. So let's say I hit it right now and hopefully it works. Yep, I get the loan is conditionally approved, which means that this loan specifically is approved for me. I hit it once more, maybe this time the loan does not get approved. It's again approved. So this time it's not approved. So this is how it works. Like this is right now deployed on a public facing subnet, like the decision service is deployed on a public facing subnet on an AWS, on AWS cloud. So we are able to hit it. What I will do is I will go back to my browser. I will type in I will actually copy the public IP, or maybe I should copy the entire thing, and I go to a dashboard. Yep. And as you can see the dashboard open, it tells me all the like loan applications that I have, whether like, I mean, it just says the loan applications that has been approved. So 3 of these were approved. So it tells me, okay, these were the approved applications and this is the approval letter. So let's say I click on any one of these, I open it, it shall redirect me to, right now it's working on Google Cloud, but it will, I can actually show you from over here. if I go to my S3 bucket, in my S3 bucket, I do have the reports stored over here, right? So all the reports have been stored over here. So which means it's supposed to be working fine. All good. Like this is how an application is supposed to be working. But let's say, what happens if AWS goes down today? Would we be able to get this data up and running? Like this is the question that we have been targeting so far. So far, so good. Everything works out of the box. Everything looks super clean, super good. Everything works. But the moment AWS goes down, this API which I just hit would not work. The entries would not be received in your databases. The files would not be uploaded to S3 buckets. Things do not work out of the box. And this is where we see like the gap with it, right? And this is where the solution targets it. So I will go back to my slides over here, move on to the slide source section again so that I can explain you stuff. So I've already told you about stateless and stateful services. I've already given you the information around this, so I think you're already aware. But yeah, now let's do a deep dive into a stateless service. So as I mentioned, my service consists of 2 microservices built on Docker and obviously can be deployed to EKS. I have deployed it to EKS. At the same time, because I have the images built, I can very well deploy it to, let's say, GKE, which is Google Kubernetes Engine, or AKS cluster, which is Azure's Kubernetes service or system as well, right? So I should have no issues in deploying this, given the fact that I already have the infrastructure set up for that. And when I say infrastructure as in terms of like where, let's say, the designing of your subnets, where does your DB resides, the buckets and all that stuff. So going back to my repo once more, this is where you would find, or you would specifically acknowledge this part of the repo structure, where I have 2 folders, one called AWS Infra and another called GCP Infra. So if you go to the folder called AWS Infra, this is where you find a lot of .tf files. TF files are technically your Terraform files, which is actually used for creating the infrastructure. So if you are not aware of Terraform, Terraform is infrastructure as a code. It just helps you to create the infrastructure in an automated manner. So I do have the Terraform file set up for AWS, and I do have the Terraform file set up for GCP as well. So both in there. So stateless services should be all good and running. The only thing that we need to take care, or we need to acknowledge in the part of stateless services is, number one, this is a new microservice which I have been building. So I obviously had the control on the code to, I obviously had the control to code in the way that I like. For a service which is already built and running, yes, things are much more difficult. But how do we actually get to stateless applications? So if you work with Python, you know that we use Boto3 for AWS services. Boto3 to connect with AWS services, and Google Client Libraries to connect with GCP services. And similarly, you have Azure SDK as well to connect with AWS infrastructure, right? But how do you make sure your code runs out of the box? So the question, or the answer to this is specifically, you do not write any vendor implementation in your code logic. You do write a vendor implementation in your code logic, but that vendor implementation would be in terms of that you only expose a certain functions which is cloud agnostic, and this is what my code does as well. So what I will do is I will go to my repo. I will show you one file which is called config.py. In my config.py file, what you would find is you have the name of the cloud service provider right now which is deployed, which is AWS, and you have the links to all the the links to all the infra that has been there, right? And if I again go back to my file on, let's say, I have a file called interface.py, or better I go to the this file on decision service, and on decision service, let's say I go to object store, right? In object store, what you would find is in this specific file, you have the cloud agnostic implementation. So the function that I'm exposing is only insert to object store, and over here you have the switch statements regarding GCP, AWS, Azure, whatever cloud you want to be, does not matter, right? So you're only exposing one function out of the box which works for anything or everything, the moment you get the cloud provider. And as I showed you, right, this is being controlled via the config statement, the config.py file on which cloud provider you want to make your stuff to. So this is more on the stateless architecture. On the stateful architecture, and I know I'm running out of time, so I would just quickly finish my talk and then open the floor to questions. On the stateful architecture, I've already shown you the Terraform bits, like how do we deploy all the specific stuff. On the stateful architecture now, so stateful is something which is not very straightforward. But you do have vendors working around it, like companies working around the specific solutions around it. But if you look from a holistic perspective, do you need the data for each and every day? Like just to keep your P0 businesses or the most important part of the businesses up and running, you actually do not need it to be like that. Like you can just take a dump of your, let's say, last 2 days, 3 days, 4 days of data and still make sure things work out of the box. I mean, things work because that's how most of the business operate. And hence, like just to give you an example, I do have certain workflows in my GitHub account, so on my GitHub repo. So if I go back to the repo, I go to the GitHub workflows, you would find some GitHub Actions files over here, and one is called sync S3 to GCS file. So as I mentioned, if I just just change the cloud provider from AWS to GCP, obviously I will lose all the data because the approval letters are there in the S3 bucket. What happens if like I want them in the GCS, like which is the Google Cloud Storage? So if I go and run this action, you would actually find like I do have some specific configs to do it. So run workflow, and you would see how many days of data do I require or how many objects do I require. So I can always set that amount, run this, and it would be automatically transferred. So this is more on the stateful side of things. Database is technically hard to manage because again there would be junk of data or terabytes of data around here, so not want to get into that. But one of the ways that you can handle is obviously setting up sync pipelines which will do this job and only take out the limited data which is available for you. The main thing that I want to take out of this specific lecture is incidents like this does not happen every day. It's once in a blue moon, right? So you only need certain businesses to be up and running, which means you should be okay to lose certain parts of the data while the outage is going on. And then once things are back, you are again back to business as usual, right? So you should be okay in giving up certain parts of the data just to get that advantage that your business is up and running. I will just quickly skim through my rest of the slides if there is anything interesting to you. This is the GCP architecture. So I did show you the AWS architecture. GCP is a bit different because GCP does not have a concept of public and private subnet. It's more about the instances that make it public or private. So unlike AWS Cloud, you would not find the public and the private subnet written over here. You would have only one single VPC network. And that is what my Terraform files also does. Like you have to factor in the challenges or the architecture of different cloud providers. So while I have not directly worked with Azure, I think GCP and Azure are quite similar, whereas AWS being the oldest cloud has a lot of complexity. So I think you can reuse the Terraform files for GCP and Azure, whereas AWS architecture has to be kept separate. So this is one of the things that you need to absolutely take care of while designing a solution for both stateless and stateful architecture. So yeah, with this, I think I did hurry about the slides, but with this, I would like to finish my talk and open up the floor to any questions. So more than happy to take up the questions now.
Thank you so much, Mr. Anubhav. So the floor is now open for questions. Anyone who would like to ask our speaker, feel free to take the mic.
Hi, good afternoon. Just as a background, I also am working on doing cloud agnostic approach in my current company. So my question is, did you ever consider just using containers for cloud agnostic approach, so that if something goes wrong in one place, you can just move the containers to another one, and so on and so forth?
Yep. I think if I got your question correctly, because your mic was a bit off the track, so I was not able to hear you well. But this is what I just did mention in my answer to stateful services. So the containers, like the images that you build, right? The containers that you build, those do not care about the cloud specific implementation. Yeah, I mean, obviously you would have the code where you have the, like I was showing you, the vendor agnostic implementation, that definitely has to be there. But containers or images at the end of the day are more or less stateless services. Stateless services means you can anyways build the image, right? Once the image is up and running, provided you have the vendor agnostic implementation in place, provided that it's not like you have written an AWS implementation using Boto3 everywhere and then try to deploy to, let's say, GCP. Yes, the container will get deployed. Yes, your service would be up and running. Health check would pass, but would your business move forward? No, that's not the case. So provided you have that vendor agnostic implementation, which I just showed you, and I can just show you back again if stuff is not clear. So if I go back to, let's say, decision service, I go to the object store, and in the object store I go to object operation.py. This was the vendor agnostic implementation that I was talking about. Provided this type of code is there in your is there in the for the system for which you are trying to build the image, then yes, like that is the solution for stateless apps moving forward. I hope I was able to answer your question. Thank you. I'm not able to hear you. Maybe you could come forward. Where is that supposed to? Yeah, so this is the code for the shim layer, right? Shim layer is technically like you have the application, you have one layer, which is like the vendor agnostic layer, right? So like when users hit or like when your service hit, it actually hits the shim layer and not your code part per se, right? So technically this is code as a shim layer because this is already embedded as a part of your code. If you want, like if the requirement is as such, you would always make it as a separate library, import it and make it as a shim layer. But this specific part, like one of the examples that I've been showing you, is the shim layer. So if you look at this, like if you look at the definition of the function, right, it just specifies what cloud provider you are supposed to hit. It does not say anything else of that sort, right? Everything is handled internally. So when your service hits this specific function, it just needs to know on what cloud your specific implementation is running and things fall out of the box. So this is the example of the shim layer. It's shim layer as a code, but if absolutely required, you could always make it as a library, expose it and do the stuff. So to answer your question, this is one component and this is one part to do it, and I appreciate your question coming up. There's one more way via which you can achieve it. So there is something called Dapper. I think you can explore this. So Dapper runs as a sidecar container, and that is also one of the ways of having a shim layer. So every call comes to your Dapper. Dapper is like one of the images that you could find, which actually is built for this specific purposes. So the call comes to your Dapper. Dapper takes care of that shim layer abstraction and then passes your code forward. So it's a kind of proxy layer in between. So both the solution works. I did shim layer as a code approach, but if you want to explore Dapper, it's also one of the possible ways to do it. So I hope. Yes. Shim layer always has to run on the application side because shim layer independently cannot exist. I mean, you could obviously have a service, right, which does all this stuff, convert, this entire logic could also be written as a service or as a library to do that stuff. But then that becomes a single point of a failure because every application is hitting that, right? So let's say something goes down with that service, even if the cloud does not go down, your plethora of services goes down. So there are ways to achieve this: shim layer as a code, shim layer as a service or as a library, and then again the Dapper. My implementation is shim layer as a code. I know it might not be the most scalable, most suitable solution, but definitely works as it is. On-prem, maybe. I mean, I do not have an experience of working with on-prem, so I need to see if this works. Should work, but yeah, it was majorly for the cloud providers.